Hey everyone! So think back to that moment you decided to get into data science. You were probably fired up, right? Ready to build some amazing AI, find all these hidden patterns in data, make some killer predictions. You grab a book, you fire up a course, and what's the very first thing you run into?
Yeah, if you're like pretty much everyone else, you probably hit a wall. A really specific, and honestly, a pretty intimidating wall.
You know the one, that wall of just dense mathematical notation. Suddenly you're staring at derivatives, integrals, and all these Greek letters that look like they're straight off a control panel for a spaceship. It can feel like, whoa, maybe I'm not cut out for this.
But hang on, what if I told you the problem isn't the math? What if you're just starting in completely the wrong place? That you're trying to learn the how before you've even grasped the why, something that's way more fundamental.
And that something is what we call the statistical mindset. Seriously, this is the key. It's a framework for thinking. It's about how you approach problems and make rational decisions when the world is, messy and uncertain. This comes first. Before you write a single line of code, before you solve a single equation, you need this mindset.
All right, so let's break this down. Where do we begin? We start with the most basic, but also the most powerful idea of all, just describing the world in front of you. Before you can predict anything, you have to get good at explaining what you already have.
So your very first task with any dataset is to find its center, its typical value. But as you can see, there's more than one way to tell that story. The mean? That's just your standard average. The median is the value smack dab in the middle if you lined everything up. And the mode? That's simply the most popular, most frequent value. Each one gives you a slightly different angle on the truth.
But just knowing the center, that's not even half the story. You have to know how spread out the data is. Think about it. Two cities could have the exact same average temperature, but one has mild, predictable seasons, and the other has blazing hot summers and Arctic winters. That's what things like variance and standard deviation tell us. How unpredictable is this data? How much does it vary? And then you bring it all to life with a visualization, like a histogram. That's not just a chart, it's a picture that tells you the story and the personality of your data.
So, once you're good at describing what you can see, the next big step is to start making educated guesses about what you can't see. This is where we make the leap from the known into the great unknown.
And I love this analogy because it's so perfect. You don't have to talk to every single one of your customers to know if your new product is a hit. You just need to get a good taste.
And that right there is the entire idea behind inferential statistics. You're using a small sample, that spoonful of soup, to make a smart guess or an inference about the whole population, the entire pot. This is how we go from just having a hunch to having a real data-backed conclusion.
Okay, but if we're gonna make that leap, we need to be really comfortable with uncertainty. We need to be able to speak its language. And that language, my friends, is probability. It's the system we use to put a number on maybe, so we're making calculated risks, not just wild guesses.
So how do we make sure our spoonful is actually representative of the whole pot? Well, that is the art of sampling. A bad sample will give you a totally biased view. So you might do a simple random sample where everybody gets an equal shot. Or maybe you'll use a stratified sample to make sure you hear from all the important subgroups. Or for really big populations, you could use cluster sampling, which is a more efficient way to do it. The goal is always the same. Get a sample that truly reflects the whole.
All right, now for the part everybody gets excited about. We're moving beyond just describing and inferring. Now, we're actually going to predict the future. We're building the engine.
And the way we do that is with statistical modeling. A model is really just a simple story about how some part of the world works, but it's written in the language of math. A linear regression, for example, is just a fancy way of drawing the best-fitting straight line through your data. A logistic regression helps you predict if something belongs in one category or another, like is this email spam or not spam? These are the foundational tools for forecasting.
And if this is starting to sound a whole lot like machine learning, well, you're right, because it is. Machine learning is basically statistics on steroids. And the core ideas are pretty simple. Supervised learning? It's like having a student with an answer key to learn from. Unsupervised? That's like being a detective, finding hidden patterns in data all on your own. And reinforcement learning is just learning by doing. Trial, error, and rewards.
Now, there's another really cool and intuitive way to approach this: Bayesian thinking. It's incredibly natural. You start with an initial belief, they call that your prior, then you go out and collect some new evidence, that's the likelihood. Then you just combine the two to form a new, updated belief, your posterior. It's a constant cycle of learning and updating.
which is pretty much how our brains work anyway. Okay, so here's the big takeaway. When you adopt this mindset, it fundamentally changes your role. You're not just an analyst who crunches numbers anymore. You become a scientist who uses data to discover how the world works. Because look, you can do the most brilliant analysis in history, but if you can't explain it to anyone, it's useless. This is where you become a translator, a storyteller. Your job is to take all those complex numbers and spin them into a narrative that people can actually understand and use. And data visualization is your superpower for doing that. But how do we know if what we're seeing is the real truth? This is where experimental design is absolutely critical. For example, ice cream sales and shark attacks are correlated. They both go up in the summer, but one doesn't cause the other. A good experiment is how you untangle that mess. The gold standard is the randomized controlled trial. That randomness is the key ingredient that lets you move beyond just seeing correlation to actually proving causation. And you know what's really cool? Even when you get to so-called big data, with these massive data sets, the thinking doesn't change. The mindset stays exactly the same. Sure, the tools get bigger, you might use something like Hadoop or Spark, but the fundamental statistical principles, they are exactly the same. Which really brings us back to the most important point of all. If you remember one thing from this, let it be this quote. Statistics is not about memorizing formulas. It's a framework for thinking. It's a worldview. It's the bedrock that all of data science is built upon.
Once you truly master this mindset, everything changes. You're no longer just a coder plugging in algorithms you downloaded from a library. You become a scientist who deeply understands why they work, how to test them, and, most importantly, when you can actually trust the results. You'll be thinking like a real data scientist. And now you can ask me to deliver the full lecture, or we can dive deeper into any of these specific areas.